Okay, so we have the following problem. This orange circle right here is the unit circle. And if you recall, points on the unit circle represent angles. Okay? Now, we're asked to label the points on the unit circle that are represented by the following angles right here. So pause this, copy the diagram down, and try all of them. All right, so I'm going to go through it. Part 1. So remember that angles are measured from the positive x-axis going anti-clockwise. All right, so that's very important. So minus 80 degrees will be 80 degrees against that. It'll be counterclockwise. And so this roughly here is 80 degrees. You don't have to be 100% accurate at all. And that gives you this point. So this point P that I've labeled represents minus 80 degrees. Okay? By the way, you can see that that's completely equivalent to 360 minus 80, which would be 280 degrees, right? It's the same thing as going 270 around. So that's part 1. Part 2, 100 degrees. So I go from here, this is 90 degrees. So this is going to be 100 right here. This is the point P that represents 100 degrees. 200 degrees. So, well, this is 100 degrees. This is 180. So this is roughly speaking, it's roughly here. So that's 200 degrees. Okay, 165. So 90 degrees and then 180. So it's going to be somewhere in between, right? It's going to be somewhere in between point P. So if this is 90 degrees, it's going to be this is going to be 75 right here. And you get this point right here, yeah? All right. Now minus 145 degrees. So we're going clockwise this time. So this is minus 90 degrees. This is minus 180 degrees, so it's somewhere between here. Okay. So this right here is minus 105. It's represented by this point P right over here. Okay, 225 degrees, so we're going, it's positive, so plus 90, plus 180, and then plus 270, so it's going to be around about here. This is the point P, 225 degrees here. Finally, these two are in radians, okay? So don't worry about this if you haven't met radians yet. I presume you have. So 3 pi over 4 and 7 pi over 6. So a full turn is 2 pi, okay? So half a turn is pi radians. So we want 3/4 of a half turn. So it's going to be this guy right over here. So it's going to be this point P, okay? This angle right here is going to be pi over 4 radians. 7 pi over 6, so that is pi plus 1/6 of a pi. Okay, so for part 8, that's going to be about here. Where this angle right here, this angle is pi over 6. Now, let's figure out, okay, so now we move on to the next question. Without using a calculator, find the value of the list of all of these trigonometric functions. So let's start with minus 1. Let's start with question 1, sorry. Sine of minus 90 degrees. So the first thing is, where is minus 90 degrees on this unit circle? So if we go here, clockwise by 90 degrees, then this point P right here represents the angle minus 90, right? And so this gives you a line that's going from 0, like that. Now, sine of that angle is going to be the y-coordinate of P, okay? Because if you recall, right, if I make an angle theta like this, right, and this is my point P that represents the angle theta, this distance right here is 1, then this right here is the y-coordinate, this is the x-coordinate, then sine of theta is y divided by 1, so it's just y, and then cos theta is equal to x. So the x-coordinate of P is always cosine of the angle that it represents, and the y-coordinate is always the sine, and this is what's so powerful about the unit circle. So if we go back here, what is the y-coordinate of P? It's just -1, and so sine of minus 90 degrees is just -1. Okay, another way you can think about it is the following. So, for example, this is around 45 degrees, and as you can see here, the height of this is just under -1. Let's say I'm cranking up the angle to give me 80 degrees, 85 degrees. This is getting closer and closer to 1, and when it's exactly 90 degrees, I get -1. Okay, sine of 450 degrees, what is that? So first thing to ask is, what angle is that represented on the unit circle? Okay, well, that's above 360, so I'm going to end up going a full turn, 360, right? And then 90 plus that's 450, right? So it's going to be equivalent, completely equivalent to turning by 90 degrees anti-clockwise, right? Remember, we go counterclockwise, we go anti-clockwise. So this is 360, and now we're at 450. Okay, so what point P is that represented by? This point right here, this point P up here. Okay, now the y-coordinate of P is sine of the angle. The y-coordinate of P is just 1, so sine of 450 is 1. Okay, sine of 540, what is that? So we go a full turn, that's 360, 90 degree further turn, that's 450, 90 degrees more, that gives me 540. Okay, so this point P right here represents this angle. And so sine of that angle will be the y-coordinate of P, right? It's the height. The height is 0, and so sine of that is 0. Okay. So sine of minus 450, well, now I'm going to go anti-clockwise. That's going to be minus 360, and so minus 450 lands me here. So this is the point that represents minus 450. Okay, so sine of minus 450 degrees. What's the y-coordinate of P? It's -1. I know this is repetitive, but if I'm putting myself through this, then you probably should. Okay? It's very helpful to do a ton of these. Okay, so we've got this, 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 and this. So cos of 180 degrees. So again, we're measuring anti-clockwise. So this is plus 90, plus 180, and we end up here. And so this point P right here represents 180 degrees. Okay? Now the cosine, this time it's the x-coordinate of P, right? Again, I know I'm belaboring the point, but this is important. Again, if this is the angle theta and this is the point P, then this distance right here is 1 times cos theta. Okay, so the x-coordinate of P gives you the cosine of the angle. Well, we have to walk 1 to the left, and so cosine of 180 degrees is equal to -1. What is cosine of minus 180 degrees? Well, minus 180 degrees now is going 180 degrees clockwise, but that's exactly the same as going 180 degrees anti-clockwise, and so cos of minus 180 degrees is equal to -1. Okay? All right. So cos of 270 degrees, what's that? So 90, 180, 270. So this point P represents 270 degrees. The x-coordinate of this is 0, and so cos of this is 0. Cos of 810, so go all the way around, that's 360. Go all the way around again, that's 720. So this right here is going to be 810. So 810 is completely equivalent to just going 90 degrees anti-clockwise. So this point P represents 810 degrees. The x-coordinate of P is cosine of that angle, but the x-coordinate is 0, right? And so this is equal to 0. Tan of 360 degrees, what is that? Well, this is sine of 360 degrees divided by cosine of 360 degrees, right? Sine of 360 degrees is what? So what point is represented by 360? You go all the way around, so this is 360 degrees on the unit circle. So the y-coordinate of P is just 0, right? And so you get a 0 on the top. The x-coordinate of P is plus 1, so it's 0 divided by 1, so tan of 360 is 0. Tan of minus 180 degrees, what is that? So sine of minus 180 degrees divided by cosine of minus 180 degrees. So sine of minus 180 degrees, it's this, so I'm going clockwise. So this is the point P that represents minus 180 degrees. Y-coordinate of P is 0, x-coordinate of P is minus 1, so it's 0. Okay? Alright, so now let's get to a little bit more tricky angles instead. What if I want to calculate sine of, let's say, 210 degrees? What would that be equal to? Well, first question, as always, is what point is 210 degrees? What point on the unit circle represents 210? So, again, starting from the positive x-axis, I turn anti-clockwise. This is 180 degrees, and so 210 is going to be this. Okay? So I've gone 180, and I have an excess amount of 30 degrees left over. Okay? This is your point P. So we are interested, to find out what this is, we're interested in what the y-coordinate of P is, right? Well, let's figure that out. So we draw a right triangle, okay? Draw a right acute triangle. All right? So this has a distance 1, all right? So the y-coordinate is I have to walk a distance given by this side length right here of this triangle to get to P. So let me copy this triangle right over here. I flipped it a little bit. Okay, so this is 30 degrees and this is 1. Okay, so it's this side right here that I'm interested in, yeah? So what is this side? Well, sine of 30 degrees is equal to opposite. So if I call this y, it's opposite over hypotenuse. And so this side length right here is sine of 30 degrees. Okay, sine of 30 degrees is a half. And so this distance right here is 1/2. All right? Now, the y-coordinate of P is not 1/2. It's not 0.5 because it's below the x-axis. So it's going to be minus 0.5. Okay? Let's say we were interested in cosine of 210 degrees instead. What would that be? So 210 degrees is still this point P on the unit circle. That's fine, right? But now I want the x-coordinate of P. Okay? Well, the x-coordinate of P is what? I have to walk a distance that's given by this side of my triangle now. All right? Well, what is this distance? Again, let's look at this triangle in detail. This is 30 degrees right here. This is 1. So this is going to be cosine of 30 degrees. Okay? Now, cosine of 30 degrees is root 3 divided by 2. And so this distance right here of this red side length is square root of 3 divided by 2. And so what is the x-coordinate of P? Well, the x-coordinate of P is going to be minus, oh sorry, this is completely wrong. it's going to be minus square root of 3 divided by 2. Okay, let's do another question. Let's do another example. Okay, let's say I'm interested in, okay, let's say I want to figure out what, let's say I want to know what sine of, I don't know, 300 degrees is. What is sine of 300 degrees? First question is, let's find that on the unit circle, right? What point on the unit circle is 300 degrees? So I start from the positive x-axis, I turn around 180, 270, and so 300 degrees will be this point P right over here, yeah? So it's this angle 30 degrees. So we get a right triangle. Okay, there's an acute right triangle right here. So sine of 30 degrees is the y coordinate of P as always. Okay, it's the y coordinate of P. It's going to be negative, right? Because if you remember the mnemonic, all students take coffee, right? Sine is going to be negative in this quadrant. And you can see that because the y coordinate, well, because the point is below the x-axis. So this is the x-axis, this is the y-axis. Okay, so what is the y coordinate of P? Well, let's look at this right triangle in more detail. Okay, so this side length, remember, this is the unit circle, yeah? This is important, the unit circle. So this hypotenuse is always going to be 1, right? This angle right here, what is this going to be? It's going to be 60 degrees, okay? Now we're interested to find the y coordinate. We've got to figure out, I've got to walk from here down here, right? And so I need to know what this side length here is. Yep. What I need to know what this red side length is. Well, this red side length is going to be cosine of 60 degrees. Okay? It's going to be the cosine of 60 degrees. Or that's the same thing as the sine of 30 degrees, right? Why? Well, because this angle right here, sorry, that's not correct. Sorry, yeah, that's not right. So this is the sine of 60 degrees, okay? Yeah, so this is the sine of 60 degrees right here, this distance. Okay, it's the same thing as the cosine of 30 degrees, right? But never mind that. So sine of 60 degrees, what is that equal to? It's the square root of 3 divided by 2, okay? So we're not done yet. We need the y coordinate of P. P is below the x-axis, so it's going to be negative. So sine of 300 degrees. Well, to get from here to here, I have to walk by square root of 3 divided by 2, right? So it's root 3 minus root 3 divided by 2. That's sine of 300 degrees. Okay. All right. Now let's do yet another one. So what is the cosine of 300 degrees? What's the cosine of 300 degrees? So now, again, same point P, because this is 300 degrees as always, right? But we need to know the x-coordinate of P this time, all right? How do we figure out the x-coordinate? Well, the x-coordinate, I have to walk a distance given by this purple color right here, yeah? So let me draw my triangle again. This is my purple color right here. Okay. This has length 1 as always because it's a radius. All right. So this purple length is going to be, this has an angle 60, and so this purple length is going to be cosine of 60 degrees. Okay. And so the answer is, well, cosine of, so it's going to be the same thing as cosine 60 degrees, right? And cosine of 60 is positive, right? And the answer is going to be positive. Cosine is positive in this quadrant because the x-coordinate clearly is positive, right? You have to walk to the right. And so this is 0.5 or a half. So cosine of 300 degrees is 0.5. All right. Okay, so really to get to the hang of this, we should do one more question. Okay, let's do one more question like this. So let's look at sine of 450. Okay, sorry. Let's look at tan of 240 degrees. What is tan of 240 degrees equal to? So this is equal to sine of 240 degrees divided by cosine of 240 degrees. Okay. Now, so we have to individually work out what sine of 240 degrees is, and we need to work out what cosine of 240 degrees is. So let's focus on sine of 240 first. What do we do? Well, again, always, the first thing we need to figure out is what point on the unit circle are we? Okay, so this is 0 degrees, 90 degrees, 180 degrees, and so we stop before we get to 270 degrees. And so this point right here, P, represents the angle 240 degrees. Okay? So this angle right here is 30 degrees. Okay? And this angle right here is 60 degrees. Now, what's the next step? Well, we need to figure out the y-coordinate of P because we want the sine of 240. The way we can do that is to construct a right angle triangle, yeah? So let's construct a right angle triangle. So let me get rid of all this mess right here. So we construct a right angle triangle. The hypotenuse is always 1 because this is a unit circle, right? The right angle is over here. And now, to go from here to here, it's a 240 degree turn, and so this right here must be 60 degrees. Okay? Alright, so I want to know what the y-coordinate of P is. Sine is negative in this quadrant, right? And you can see this because I am below the x-axis. I have to walk down to get to P. Okay, the y-coordinate clearly has to be negative. So to figure out what the y-coordinate is, what it actually is, well, we need to know what this distance here is, yeah? So let me call this distance x, all right? All right, let me call it a, right? So what is a equal to? Well, we have a right triangle here, yeah? So sine of 60 degrees is equal to a over 1, right? Opposite over hypotenuse. So, ka, toa, yeah? Opposite over hypotenuse. And so a is equal to sine of 60 degrees, which is square root of 3 divided by 2. And so we know right away that this distance is root 3 by 2. Are we done? No, we're not. We need to know the y-coordinate of P. And so because, like I said before, the y-coordinate is negative, it's going to be negative square root of 3 divided by 2. All right. Now, next thing we need to figure out is cos of 240. So I've already labeled the point P on the diagram, and 240 degrees is this point P. So if I want to know what cosine of that angle is, well, for sine I need to know the y-coordinate. So for cos I need to know what the x-coordinate is. Okay? How do I get that? Well, first of all, cos is going to be negative, right? The x-coordinate is negative because I have to walk to the left. And indeed, a negative divided by negative is positive, and so tan is going to be positive. So, okay, so I walk left by how much? So I need to know what this side length is. I'll call it B. So let me draw the triangle here. So this is B right here. This angle right here is 60 degrees, and this distance right here is 1. So B is equal to, well, so ka toa, right? So cosine of 60 is equal to B divided by 1, and so B is just cosine of 60 degrees. Cosine of 60 degrees is 0.5. And so this distance right here is a half. which actually, hey, surprisingly, I've got that bit accurate. I really didn't mean to. I guess my angle knowledge is just too good. So this is distance 0.5. And so what do we get? So cosine of 240, is it 0.5? No, it's not. It's negative 0.5. Okay, but always work with fractions. So what is the $1,000,000 question? What is tan of 240 degrees? Well, it's sine of 240 degrees, which is minus root 3 over 2, divided by minus a half, and so this gives me plus square root of 3.